For a while now, we've all been talking to AI, refining our prompts. We've gotten pretty good at it, actually.
Yeah, we have.
But what if that era, that whole way of interacting, is, well, maybe beginning to shift?
Oh, the game has definitely moved on.
Yeah.
It really has. It's no longer just about having a conversation, that back and forth chat.
Mm-hmm.
Now it's really about architecting. It's
Yeah.
about building entire sophisticated AI applications, things that can operate autonomously.
Welcome back to the Deep Dive. Today, we're unpacking what feels like a really fundamental shift in how we interact with, and maybe more importantly, how we build artificial intelligence.
Yeah.
Our source material for this is a really compelling guide called Context Engineering, a guide to building a modern AI system.
And we're going to take a journey, basically starting from those simple one-off prompts we all know,
Right.
and moving towards the complex, really intricate architecture of these fully autonomous AI systems. Think of it like moving from just asking a single question to actually designing a complete intelligent system.
A system that can stand on its own, handle complex tasks, adapt.
Exactly. All without constant oversight.
So our mission today is to distill why this evolution, this thing called context engineering, why it's so quickly becoming the new frontier. We'll explore how it's being used to create, well, the next generation of AI, the kind that can truly operate independently, managing complex workflows without needing us there every step of the way. It's a fascinating leap, really.
It really is.
Okay, let's really unpack this first idea. For years, most of us, myself included, have been focused on mastering what we call prompt engineering.
Right, the standard practice.
Yeah, it's a very direct interaction, almost like hiring a personal shopper. You're right
Yeah.
there with them, guiding them, constantly refining your requests. Like, no, not those running shoes, maybe something with more support.
Yeah, exactly. You ask a question, they respond, you give more detail, they refine their answer. It's iterative.
And most people using tools like ChatGPT, that's pretty much what they're doing.
Yeah.
A continuous chat.
Exactly. It's very hands-on. You're always in the loop, tweaking the output. But now we've clearly stepped into what the guide calls World #2, context engineering.
Okay.
This is fundamentally different. It's about building, say, an autonomous store manager.
Oh.
So instead of guiding someone through the store, you're writing this incredibly detailed, maybe 500-page operational manual before the store even opens.
Wow, okay.
Every single scenario needs to be anticipated in that manual. Everything from processing a complex refund to handling a completely bizarre customer question nobody expected.
So the AI has to be ready for anything right from the start, no hand-holding.
No hand-holding, day one readiness.
So if we stick with that analogy, the AI's context window, that's its input area, right, where it takes in information.
Yep, it's working memory, essentially.
So that's like a briefcase.
Yeah.
And prompt engineering is like casually handing items into the briefcase one by one while you chat. But context engineering, that's being a master packer.
I like that. A master packer.
Yeah, it's the precise art of carefully organizing everything the AI needs for a long, maybe difficult journey, making sure nothing's missing, and absolutely no space in that limited briefcase is wasted.
And what's really driving this, what's fascinating, is the business imperative. It's a necessity now.
How so?
Well, think about a customer service AI for a huge online store. It just can't have leisurely chats with every single customer. It's impossible at scale.
Right, the volume is too high.
Exactly. It needs to be ready for this enormous variety of scenarios from the very first moment. Complex billing issues, refunds, login problems, weird questions, even, sadly, dealing with abusive interactions sometimes.
All autonomously.
All autonomously. And, Andrej Karpathy had that great quote that LM is the CPU and the context window is the RAM.
Oh, yeah.
The large language model, the GPT, whatever, that's the processor, the brain. But the context window is its working memory, its immediate workspace.
Okay.
Context engineering means expertly packing that RAM for peak performance so it can run on its own.
That makes a lot of sense. Handling all that complexity without constant human help is obviously huge for businesses. But why is this shift from just chatting to building these big systems? Why is it so critical right now?
Because AI needs to operate independently at scale. It has to handle every conceivable scenario from day one without needing a human to step in constantly. It's about reliable autonomy.
Okay, so the need is clear. Autonomous operation at scale.
To really engineer context well, though, we need to understand the AI agent itself, like what's under the hood.
Right.
It's not just one big black box. It's more like, well, the guide compares it to a biological organism with 6 essential organs, all working together.
Okay, Interesting analogy. So what's the first organ?
It starts with the brain. That's your core processor, the LLM.
The large language model, like GPT-5 or something.
Exactly. It's the engine of thought. Could be a big generalist model or maybe a smaller, specialized one, fine-tuned for a specific job. That choice really impacts performance, cost, everything.
Makes sense. The engine. What's next?
Then you've got the hands and feet. These are the tools and the external integrations.
So how it interacts with the outside world.
Precisely. They let the AI's brain actually do things in the digital world, like a personal assistant AI might use its hands to check your Google Calendar.
Or book an appointment.
Right. Or a financial AI might use its feet to pull live market data using an API. They're its action capabilities.
Okay. Brain, hands, and feet. What else?
The hippocampus. It's long-term memory.
Memory. That seems critical.
It is. And this is where something called RAG retrieval augmented generation often comes in.
RAG. Okay. What's that in simple terms?
It lets the AI pull in specific up-to-date info from external knowledge bases when it needs it.
So it doesn't have to have everything memorized up front or crammed into that limited context window.
Exactly. It makes it way more efficient. It ensures the AI remembers past chats, like for a therapy bot.
Right, for continuity.
Or it can grab the latest case law for a legal AI. It dramatically reduces the risk of the AI just making stuff up hallucinations, keeps it grounded.
Okay, RAG for memory. That's super important. Got it.
Next up, the mouth and ears. Speech to text and text to speech.
Making it more human-like in interaction.
Yeah, I mean, text is fine, but voice often just feels more natural, right?
Definitely. Especially on mobile or for assistants.
Right. It makes interaction easier, hands-free. It's about bridging that human-machine communication gap.
Okay. Brain, hands, feet, hippocampus, memory RAG, mouth, ears. What's left?
The conscience. These are the guardrails, the safety mechanisms.
The rules.
Yeah.
Like Asimov's laws, almost.
Sort of. It's the rule set preventing the AI from doing bad things. Using nasty language, giving dangerous advice, leaking private info.
Crucial stuff. I still wrestle with prompt drift myself sometimes, where the AI just goes off script.
Yeah, we all do.
So these guardrails feel really important. But how hard is it to set them up right? Like, define them without making the AI useless or stop at finding loopholes. Any common pitfalls there?
That's a huge challenge, honestly. It takes careful iteration, thinking about all the weird edge cases. The biggest mistake. Assuming the AI will just behave. You need tough testing, constant refinement. You got to watch out for things like prompt injection, too.
Right, where users try to trick it into ignoring the rule.
Exactly. You need robust defenses. It's about careful iteration and anticipating bad actors.
Okay, so guardrails are key but tricky.
Got it.
Is that all the organ?
One more. The central nervous system. This is kind of the hidden infrastructure.
Okay.
It handles deployment, monitoring, improvement over time. It makes sure all the other organs work together smoothly. It gathers feedback, enables updates. It's what turns a cool prototype into something solid, production-ready, enterprise-grade.
The system that keeps the whole thing running and learning.
You got it.
Okay, so we have these 6 organs: brain, hands, feet, hippocampus, mouth, ears, conscience, and central nervous system. They form the agent. But just having the parts isn't enough, right? How does context engineering actually make them work together effectively towards a goal? How do you give it that overall instruction?
That's exactly the point. It's all about writing that super detailed instruction manual, a manual for all those internal parts, telling them how to operate, how to talk to each other, how to use external info, all within that context window limit. It orchestrates everything.
Okay, it's the master plan for the organs.
Let's use an analogy from the guide. Think of making a burger.
Okay, I'm hungry now.
So you need the ingredients, right? Bun, patty, veggies, sauce.
Yeah.
You need the core components.
Sure.
But if you just handed that pile of stuff to someone who'd never seen a burger, what would they do?
Stare at it. Maybe eat the pickle first.
Exactly. Just having the ingredients isn't enough. You need the instructions, the manual that says patty on the bottom bun, then cheese, then lettuce, tomato. It dictates the structure, the relationship between parts.
Right, the assembly instructions.
And context engineering is exactly that. It's writing that comprehensive instruction manual for your AI agent, the blueprint.
Okay.
And crucially, it's not just some messy paragraph. The source describes this highly structured 4-part thing called the Prime Directive.
Prime Directive. Sounds serious. Like Star Trek.
Kinda. It's a real-world, context-engineered prompt, maybe for an AI research assistant, and it's treated almost like a legal contract.
Yeah.
Super detailed, leaving zero room for error or guesswork.
Okay, 4 parts. What are they?
Part 1, role play. Define the AI's persona. Who is it?
So for the research assistant.
Something like, you are an AI research assistant. Your focus is identifying and summarizing recent trends from reputable sources only. Sets the whole mindset.
Got it. Persona first. Part 2.
Mission briefing. This is the detailed step-by-step plan. What does it actually do? For instance, your task is to extract up to 10 diverse subtasks related to the user's query. Prioritize these by relevance. Execute them. Then, synthesize your findings into a concise 300-word executive summary. Very specific instruction.
Specific. Okay. Part 3.
Filing system. This defines exactly how input comes in and how output should look.
Ah, the formatting.
Yes, using clear, machine-readable formats. Maybe XML tags to mark the user's query within a block of text, and specifying the output must be in, say, JSON format with specific fields.
So no guesswork for the AI or for whatever system uses the AI's output. Predictable data.
Removes all ambiguity. Ensures consistency.
Makes sense. And the last part, part 4.
The rules of engagement. These are the constraints and the capabilities. Basically, the guardrails plus its tool access.
Okay.
Things like focus only on main points, avoid fluff or personal opinions, and importantly, you have access to a live web search tool. Use it for recent information. Guides its actions, ensures it uses its tools correctly.
Right. Defines the boundaries and the toolkit.
Exactly. 4 parts. Roleplay, mission briefing, filing system, rules of engagement. That's your structured prompt.
Okay, that's pretty comprehensive.
Well, wait, there's more. There's even a pro-level upgrade mentioned.
So?
The chain of density prompt.
Chain of density, what does that do?
Okay, so after the AI generates its first summary, say that 300-word one,
Yep.
This extra instruction forces it to reread its own summary. Identify maybe 3 to 5 key terms or concepts in there that aren't fully explained.
Okay.
And then here's the kicker. It has to rewrite the summary, weaving in concise explanations for those terms without increasing the total word count.
Whoa. So it has to make the summary denser, more informative, but stay the same length.
Exactly. Integrate more meaning into the same space.
That sounds incredibly difficult. But wow, imagine the output. Perfect for high-level briefings where every word has to count.
That's the idea. Executive level, precision, and density.
So this structured prompt, especially with things like chain of density, makes the AI incredibly precise for one specific complex task. But what about even bigger things? Tasks that need multiple steps or a much wider scope than a single prompt can easily define. How does it scale up?
Yeah, that's where it gets really interesting. It scales using more advanced strategies, like having the AI essentially take its own notes during the process, or by breaking the problem down and using specialized agents. Basically, the AI needs ways to manage more information or complexity than fits in one go.
Okay, so it needs strategies beyond just one big prompt. Makes sense.
Right. So beyond that single powerful prompt, professional context engineering uses these more advanced strategies. One is called writing context.
Writing context.
Yeah, it means the AI isn't just processing external stuff. It's actually taking notes on its own internal process, reflecting on its steps, its decisions.
Like keeping a log of its own thinking.
Sort of, like a chess player tracking their strategy. It helps it maintain context over longer, more complex tasks, and even improve over time.
Okay, that's different from selecting context, right? That sounded more like RAG.
Exactly. Selecting context is the AI doing its own research using RAG, dynamically pulling in specific info from a knowledge base when needed. So one is self-reflection, the other is external research.
Hang on.
There's compressing context if you've got just massive amounts of data coming in.
Which happens a lot.
Yeah. This involves using smart techniques to summarize or prioritize that data, basically squishing it down to fit efficiently into that limited context window. Keeps costs down, performance up.
Essential for practicality.
And then isolating context. This is really key when you start talking about multi-agent systems.
Okay.
You create smaller, focused contexts for different agents. Each one becomes an expert on its specific piece of the puzzle, avoids getting overwhelmed by too much irrelevant info.
Specialization. Which brings us to the scaling question you mentioned. The guide talks about multi-agent systems or agent swarms.
Yes. This is really seen as the frontier. It's the huge difference between hiring one super smart generalist who has to do everything.
Who probably gets overloaded.
Right. Versus assembling a whole team of elite specialists. Each expert focuses on their part, but they coordinate.
Like building a company versus hiring a one consultant.
Exactly. Agent swarms offer huge benefits. You get higher quality because of specialization. Better scalability, just add more agents if needed. Debugging gets easier because each part is simpler. And often, overall performance is better for really complex tasks.
Can you give an example?
Sure. Think about an AI travel planner. You could have one agent that's an expert flight booker, another is a hotel specialist, a third finds local activities, a fourth manages the budget.
Okay, each doing its own thing.
Each an expert. The big challenge, though, is designing how they talk to each other. Those communication protocols need to be really clear and efficient so they work as a team.
That sounds incredibly powerful, almost like the ultimate solution for complex AI tasks. But coordinating all those agents, making sure they communicate effectively, doesn't that add a whole new layer of complexity? Are there big downsides or overheads compared to just using one big agent?
Oh, absolutely. That orchestration is definitely complex. Designing robust communication, handling errors between agents that adds overhead, it's a trade-off. But for really big, messy problems, the power you gain often outweighs that extra complexity. The benefits and capability can be huge.
Okay, so there's trade-offs, but for complex tasks, swarms win. Got it.
And the really cool thing is, these core ideas, structured prompts, agent organs, swarms, they're platform agnostic.
I mean, they work anywhere.
Pretty much, whether you're using a visual tool like NANN to drag and drop workflow.
Like a no-code approach?
Yeah. Or a developer framework like LangChain, writing Python code. Or even building totally custom solutions. A well-designed context, that prime directive prompt, acts as a universal blueprint. It tells the AI how to behave, no matter the underlying tech stack.
That's powerful. It means the design principles are transferable.
Exactly. And this lets people build amazing real-world applications right now. We're seeing automated customer service that can handle complex stuff, refunds, escalations, database lookups, all while sounding like the brand. Sales agents, qualifying leads, sending follow-ups, scheduling meetings, all on their own.
Wow.
Even sophisticated content systems, generating, reviewing, editing, publishing content across platforms, sticking to brand, voice, and legal rules. The possibilities are just exploding.
It's moving fast. But,
Yeah.
okay, building the agent is one thing. How do you make sure it actually works reliably? Quality assurance seems critical.
Oh, it's absolutely vital. You can't just build it and hope for the best. You need rigorous testing, scenario testing, especially for those weird edge cases you didn't think of initially.
Testing the unexpected.
Yeah. And then continuous monitoring once it's live, tracking success rates, errors, user feedback, and crucially using that data to iterate and refine. Your first prompt, your first agent design, it's almost never going to be perfect.
So it's a cycle. Build, test, monitor, refine.
Constant learning and adaptation. That's the name of the game.
And looking ahead, what's next for context engineering?
The future looks pretty incredible. We're definitely seeing much larger context windows coming.
Meaning AI can handle more information at once, remember more.
Exactly. Leading to more coherent, more capable systems. We're also seeing huge strides in multimodal integration.
Not just text, but images, audio.
Yep. Visual audio inputs, which will demand entirely new ways to structure that information for the AI, new kinds of filing systems.
Fascinating.
And maybe the most mind-bending thing, eventually we might see AI systems optimizing their own context engineering, basically learning how to write better prompts and build better internal structures for themselves.
Whoa. AI improving its own fundamental design. That's something else. Okay, so if someone listening is thinking, I want to get started with this, what are maybe 5 concrete steps they could take?
Good question. Okay, first, start simple. Don't try to build a massive swarm on day one. Pick a single agent for a clear, well-defined task, like maybe drafting standard emails.
Okay, start small.
Second, focus on clear, structured prompts. Use consistent formatting, like those XML or JSON examples. Structure is key.
Structure matter.
Third, test rigorously and document what works and what doesn't. Keep track of your experiments.
Test and learn. Fourth,
learn from others. Look at existing examples, best practices, guides like the one we're discussing. Don't reinvent the wheel entirely.
stand on the shoulders of giants.
And fifth,
and maybe most crucial, stay current. This field is moving incredibly fast. Keep reading, keep experimenting, keep learning.
continuous learning. Got it. So summing it all up, what's the single biggest takeaway? If someone remembers only one thing about shifting towards context engineering, what should it be? I think it's realizing you need to shift your mindset. Move from just prompting an AI, having a chat with it, to actually designing its architecture. Thinking like an engineer, not just a user, that's the fundamental shift.
From prompter to architect, designing the system, not just talking to it. So the big idea here seems really clear. The era of just having a clever conversation with AI, while useful, is evolving. We're fundamentally shifting roles.
Yeah.
From being prompters to becoming architects of these complex AI systems.
Exactly. It's all about building sophisticated, well-architected systems. Systems that can handle complex jobs autonomously, safely, reliably, and performantly right from the start.
You're not just reacting to what the AI says, you're proactively defining its entire operational framework.
It really is like moving from being that personal shopper, guiding someone one step at a time, to creating the entire self-managing department store. Pre-programmed to run smoothly, handle anything, and maybe even adapt on its own.
Writing the instruction manual for the perfect burger, not just picking out the ingredients.
Yeah. Crafting the AI's operating system, in a way.
So what does this mean for everyone listening? As AI gets woven deeper into, well, everything, business, daily life, understanding context engineering seems like it's going to be a really crucial edge.
I absolutely believe so.
It's not just for hardcore AI researchers anymore, is it?
No, not at all. It's becoming a core skill set for anyone building with AI. It's the difference between someone who can, have a fun chat with an AI
Which is cool, but limited.
and a professional who can build a real working AI-powered solution, something that delivers consistent, reliable value for complex challenges. This discipline, context engineering, it pays huge dividends in terms of capability and reliability.
Building something truly useful and robust.
Exactly.
If this deep dive has sparked your curiosity and you want to really get into the nuts and bolts, remember you can always check out the source material we discussed for much more detail and those practical examples.
It's definitely worth digging into.
Thank you for joining us on this deep dive into the really fascinating world of context engineering. Until next time, keep learning.